The people here grow colder. I turn to my computer and spend my evenings with it.
Hello, and welcome to Fahrenheit AI, episode 26. Today, we're going to take a step back and look at how to collect production data. We're going to check out using AI to create SOPs, using online forms, and IIoT. I get asked quite a bit how to collect data inside of my screen print shop or factory because employees find it difficult. It takes a lot of training, and a lot of errors can be made. It seems like a really tedious task. A lot of the examples that I provide were collected manually using spreadsheets, and of course, that's an option. There are other options available today. I want to explore a couple of them. The first one is Scribe AI. This is a tool that can help you to create SOPs. The SOPs themselves don't have to be digital SOPs. They can be manufacturing SOPs, and the AI can help you write them. First, we're going to look at a training document that I made for making one color separation, two color separation with an underbase, or a separation with a fade. It goes through step by step and teaches you how to do this in Photoshop. Scribe allows you to copy and paste specific steps to someone. You can also link videos. Scribe watches you use your computer and then documents the whole thing. Scribe also has a community of procedures that have been created by other users that you can access. Next, you can create your own SOPs. In order to test out Scribe's SOP function, I decided to use one that I had previously developed. It's an SOP about pigments in a water-based system, proper storage, and handling. I put that in as the title, and I asked the AI to create an SOP. I gave it all of the different areas that I wanted the SOP to cover, like prerequisites and scope and definitions. After I had identified every subject matter, the AI created an SOP from the beginning. Now, it wasn't able to hit the specifics of my SOP, the specific reasoning behind my factory needing to have an SOP for this procedure, but it covered things like safety, handling, how to clean up, who was responsible. It fleshed out the SOP very well. All I had to do was go back in and add the specifics of my particular handling scenario, which required turning the pigments periodically so that the sediment wouldn't create dilutions in the color and durability issues on the press. The process took minutes versus however long writing an original SOP from scratch or having to rebuild it from a different SOP would take. Because it's in this platform and it's an AI space, you can build them off of each other and it will start learning your SOP. They will all read the same, be easily updated, and the AI will assist you through the process. You can also tie in the training procedures. If I wanted to tie in the separation training somehow, I just add it to this procedure and send it to my team. A method for data collection inside of a production factory is to use online forms. It's easier than using spreadsheets. Online forms can be accessed through tablets, handheld devices, through desktop or laptop devices. They're able to be updated real time, and they can be tracking real time. They pick up some of the slack of a spreadsheet. For example, you can use tools like JotForm, which is very popular. I tested one called FastField. In FastField, I developed a form for setup times based on the spreadsheet collection that I used to do. Inside of my form, I have job number, barcode options. So if you are working off of barcodes, it can scan the barcode. I have date and time, number of screens, number of special effect screens, setup time start, finished sample for QC, unfinished sample reason, minutes per screen, QC time start, approval, QC photo, and manager acknowledgement. Inside of the form, the operator fills out each section. The operator can hit the start button first, or you can designate when the start button is supposed to be hit. They enter the job number or scan the barcode. By hitting start on the timer, it's timing the operator. They enter the date and time, but I set it to automatically fill based on interacting with the form. The number of screens in this example is 3, and there's 3 special effects. So every screen is a special effect. This is reflected in the minutes per screen calculation that is done. If this was put on a tablet that's attached to the press, the operator hits start and they do the setup. When they're done and they're ready to show the QC, they hit pause and they say ready to show QC. The shirt and the form goes over to the QC and they hit start. Then you have a QC approval and photo. If QC rejects the sample, they give a reason, and that's added to the unfinished sample reason. When it's completely finished, the operator can go to the manager, and the manager checks off the times look accurate based on what they observed that day. The form is automatically submitted. All of the forms get submitted, and you have data analytics against all of that workflow. Generally speaking, you're asking an operator to be accountable for their work. They don't have to figure out the math. They're basically entering a start time and a finish time. This gives you access to employee performance data, preventative maintenance data, QC performance. You have finished QC sample pictures at the time of approval. The interaction takes seconds. You can create an AI SOP that trains them on how to do this. This specific example, we go up to 4 minutes and 30 seconds, and that reflects as minutes per screen of 1 minute per each of those 3 screens. If you look at the math that we did on the calculation for the minutes per screen, we're taking the total time and we're dividing it by the number of screens. So 3 minutes divided by 3 screens would be 1 minute per screen. We're adding half of the number of special effects screens to allow an extension for the time because special effects take longer to set up. So in this case, 3 flat screens, 1.5 special effects is 4.5. 4.5 minutes divided by 4.5 is 1 minute per screen. This will be reflected in your summary data, and it will show you how many special effects screens you have and how that's affecting your setup times.
In 1982, researchers and students in the computer science department had a serious problem. They'd often find themselves walking to the building's Coca-Cola vending machine, only to find it was either empty or the drinks were too warm. Serious stuff. So naturally, they came up with a way to connect the university's Coke machine to the internet. This way, they could check the status of the machine remotely before making the trek to grab a beverage. History was made. It just didn't feel like it at the time. Michael Kazar, who was a Carnegie Mellon grad student at the time, told Politico in a 2015 retrospective, "It really was not a very significant thing at the time. There was a Coke machine on the 3rd floor of this 8-story building, and people didn't like the fact that they would go down all the way to the 3rd floor and discover the Coke machine was empty." According to IBM's Industrious blog, students installed micro switches in the bottle-based vending machine to keep track of the fill state of each column. They also tracked how long the bottles had been inside the 1970s machine. To determine whether drinks were cold enough, they installed temperature sensors. The most innovative part involved connecting the machine to the university's network. Students designed a board that interfaced with the machine's sensors and connected to a computer. Custom-developed software queried the connected computer for the machine's status. Using could send a simple command from any terminal in the network, and the program would return info about the drink situation.
At its core, a sensor is a device that detects changes in its surroundings. Nowadays, we have sensors that can detect sight, touch, sound, smell, and even taste. Without these sensors, the conveniences we take for granted in our homes and workplaces would be much harder to achieve. Take driving to work as an example. The traffic lights at intersections often rely on sensors embedded in the road, which detect when your car arrives. Or consider automatic doors at a grocery store. They open because a sensor senses your approach. In industrial environments, sensors play an equally important role. They monitor variables like temperature and pressure in batch processes, allowing systems to automatically display and control these conditions.
Looking to the future, the industrial Internet of Things allows our factories to become smarter. This is Industry 4.0. This is taking that data collection to the next level because it's becoming autonomous. This is the future. It's also the present if you're willing to make the investment. You can go from spreadsheets to online data forms, online connectivity, to interactive tablets, to sensors and video. Sensors will do things like forklift management through indoor location tracking or safety through real-time tracking of people and machines. Real-time efficient allocation of resources through accurate tracking, knowing how much you have in inventory and in your warehouse. Pulling and picking on autonomous vehicles and using sensors to know when things need to be reordered. Machine learning and AI tools in IIoT applications allow for trend detection, statistical trend and pattern detection for business KPIs. It looks for anomalies, auto-detects deviations from normal behavior, and it can predict. Predicting the future state by learning from machine data and business context. And this is where it can become really, really powerful for your business. Without those tools, your information gets stuck in silos. And reactive processes lead to inefficient manufacturing. Unpredictable equipment failures and maintenance costs result in expensive downtime and factory managers struggling to maintain quality and yield. This is the result of not engaging in active data collection with feedback. The more real-time the feedback and the more predictive and analytical it is, the more effective it will be in profitability and maintaining production capacity. Thanks so much, you guys.
It's the